Chapter 5, Section 4 is about the triangle midsegment theorem. So by the end of this lesson, you should be able to prove and use properties of triangle midsegments. So what is a midsegment? It is a segment that joins the midpoints of two sides of a triangle. Every triangle has three midsegments, and they form a midsegment triangle. So if we were looking at side AB, the midpoint would be somewhere here. Let's call it D. And the midpoint of BC would be somewhere probably here. Let's call it E. And the midpoint of AC would probably be somewhere around here. We can call that F. Now the midsegments connect these. So DF is a midsegment, DE is a midsegment, and EF is a midsegment. And as you can see, they form this nice little triangle inside of here, which is called the midsegment triangle. So midsegments versus medians, they both kind of have middle worked in there, but midsegments connect midpoints. Where remember, medians go from a midpoint to a vertex. So these connect midpoints and vertexes. So let's explore one. The vertices of triangle XYZ are at -1, 8, 9, 2, and 3, -4. M and N are midpoints of XZ and YZ. We need to show that MN is parallel to XY and that MN is 1/2 of XY. So let's go and plot our points. There's X. Y is over at 9, 2. And Z is at 3, 4. -4, sorry. So we connect the dots. This nice, pretty little triangle. So let's find the midpoint of XZ. So remember, that's just the average of our 2 points. So take your X's, add them up, divide by 2. Take your Y's, 8 and -4, add those up, divide by 2. So we end up with 2/2, which is 1, and 4/2, which is 2. So the point 1, 2, over 1 up 2, this is one of our midpoints. So let's make this M. And then we got to find the midpoint of YZ. So again, take your X's, 9 plus 3, and then take your Y's, 2 plus a -4. So this time we get 12/2, which is 6, and -2/2, which is -1. So over 6 down 1, right here. Let's call this N. So MN, when we connect our two midpoints, we get a nice mid-segment here. So then we have to prove two things. We got to prove that MN is parallel to XY. And they kind of look parallel here. They're kind of running in the same direction. So to prove parallel, we got to prove that the slopes are the same. So let's find the slope of XY. So we're going to take our Y values and subtract them, divided by our X values and subtract them. So we end up with -6/10, which is reduced to -4/5. So now let's find the slope of MN so that we can compare them. So remember, we just found these 2 points for MN, so let's subtract our Y's and then subtract our X's, and -4 on the top divided by 5 on the bottom. So these 2 things right here show us that because the slopes are the same, MN has to be parallel to XY. The other thing we have to show is that this distance here, MN, is 1/2 of XY. So we need to think back to the distance formula. And I know it's been a really long time since we've done this one, But the distance formula is the square root x2 minus x1 squared plus y2 minus y1 squared. And you take the square root of that whole thing. So let's find the distance of mn first. So we take our x's, so here and here, 6 minus 1, and we're going to square it, plus our y's, we're going to square it. So we end up with the square root of 5 squared plus negative 3 squared. This gives me 25 plus 9. When I add those up, I get the square root of 34. That's a distance. We could type it in our calculator, but let's just see what we get. And now we got to do the same thing for xy. So xy, the square root of x is here, y is here. So 9 minus the negative 1 plus 2 minus 8. So we get the square root of 10 squared plus negative 6 squared, which is 100 plus 36. And we get square root of 136. Now remember our goal. We're trying to prove that mn is 1/2 of xy. So now we are going to need a calculator. And we want to know if the square root of 34 is 1/2 of the square root of 136. So let's type them into our calculator. Square root of 34 is 5.83. Square root of 136 is 11.66. So if we cut that in half, we get 5.83. So they're equal. So we know that mn is 1/2 of xy. So all of this work was to prove this mid-segment theorem. And that says a mid-segment of a triangle is parallel to the side of a triangle, and its length is half the length of that side. So we know two things. If D is the midpoint of AB and E is the midpoint of BC, when I connect these, it's going to be parallel to this, AC, and it's going to be 1/2 the length. So of course we're going to use that to do some algebra, like this. So find each measure. Now all of these little slashes here are telling us that B is the midpoint of AC. Here it's telling us that D is the midpoint of CE, and then here it's telling us that F is the midpoint of AE. So because we know all of that, when they're connected to make this mid-segment triangle, we know several things to be true. So the first thing it asks us to find is how long is B to D. Now what you want to do is find the segment that's parallel to it, so that's this, AE, and you know their relationship is half. So if AE equals 17, BD equals 1/2 of 17. And half of 17 is going to give us 8.5. That one was pretty easy. Now the next one's a little more confusing. I want to find angle CBD. So I want to find this angle right here. And the only angle measure they give us is this guy over here. So what I'm going to do is take a look at everything that's going on here. This angle right here is cut by two things. It's cut by this line and this line. That's how that angle is formed. Now, since we're finding angles, we want to use something like the alternate interior angle theorem. So in order to do that, we have to have parallel lines. So this line right here, DF, is parallel to this line here. And then this BD acts as our transversal. So if you know this angle right here, alternate interior angle theorem says that we know that angle right there and that they have to be equal. So angle CBD is also 26 degrees by alternate interior angle theorem. And that's it. So you should be able to prove and use properties of triangle midsegments. We already proved it, so we will be focusing a lot on the using it in class tomorrow. Make sure you write down any questions you have, and we can go over them then. Have a good night.